Have you noticed weather patterns becoming more extreme and lasting longer, perhaps a prolonged heat wave or a stubborn cold snap? You might wonder what causes these unusual atmospheric events, and surprisingly, the answer often links back to changes happening far away in the Arctic. Arctic warming makes the jet stream wavy because it reduces the critical temperature difference between the cold Arctic and the warmer mid-latitude regions. This weakened temperature gradient slows down the powerful, high-altitude wind current known as the jet stream, causing it to take on a more meandering, wave-like path. Normally, a significant temperature contrast between the poles and the equator drives the jet stream, creating a fast-flowing river of air that generally moves west to east. This strong, stable current effectively keeps cold air bottled up in the Arctic and warmer air in the south. However, the Arctic is warming at a rate 2 to 3 times faster than the rest of the planet, a phenomenon known as Arctic amplification. As the Arctic warms, this temperature difference lessens, which in turn diminishes the force driving the jet stream. Imagine a fast-flowing river being slowed down. It starts to meander and form larger bends, just like the jet stream now does. These amplified waves in the jet stream can become almost stationary or get stuck for extended periods. When the jet stream's waves become more pronounced and less progressive, they can cause weather systems to linger over regions for days or even weeks. This leads to prolonged extreme weather events, such as extended droughts, intense heat waves, unusually long cold spells, or persistent heavy rainfall in specific areas. Understanding this connection helps us anticipate and prepare for these more frequent and intense conditions. The atmospheric waves we are talking about are also known as planetary waves or Rossby waves, which are a natural feature of atmospheric circulation. The critical insight from recent research is that the reduced temperature gradient due to Arctic warming appears to be enhancing these waves, making them larger and slower moving. This area of study is crucial for improving long-range weather forecasting and climate projections, as it highlights a direct pathway through which changes in a distant region can profoundly influence daily weather patterns in populated areas far to the south. Ultimately, the wavier jet stream underscores the profound interconnectedness of our planet's climate systems. By understanding how changes in the Arctic directly influence global weather, we can better prepare for future climate shifts and the increasingly persistent extreme weather events that may accompany them, allowing us to adapt and build resilience in our communities.